Well, thank you, Gretchen and Chris, and thank you, McGill and Tyson, for giving me this opportunity to talk. And I'll jump right into it. So, as she just laid out, we're in this transition from the old world of centralized power based on fossil fuels with high emissions to a future world of clean distributed power. And the question is, how do we get there? But first, let me just talk about why I'm here. You know, I'm the founder of the Homer Energy. I created this software at the National Renewable Energy Laboratory 25 years ago with the vision that distributed decentralized power was the future. And it was a research project for a long time, but we put it up on the web. It took off on its own. The Department of Energy, in its infinite wisdom, killed the Village Power program that was originally part of. So I licensed it out of the lab to create a private company in 2009. It's now become the global standard for designing microgrids, for the sort of conceptual and feasibility analysis of what technologies go into a microgrid. And my definition of microgrid is really simple. It's any system that can stand on its own. But there's a lot of new technology available, and it's a little confusing what technologies make sense where. And it's not a one-size cookie-cutter kind of Model T solution, unfortunately. So our software helps people figure that out. We put on conferences every year. This one we're going to do close to home. We're in Boulder, Colorado. We're going to do it in Denver, just to make it easier on ourselves. But our user base is truly global, which is the point of the pie chart on the left. And the point of the graph on the right is to show how much traction this concept of microgrid is getting. And I put in, when we spun off from NREL, you can look at that two ways. Either our timing was really good. I prefer to look at it as we've helped create the global interest in microgrids. Might be a little self-serving. But I do think, more importantly, the interest is really growing rapidly in the last few years. So, so just in the last 2 years, we've been collecting data from our users. And this is where they're looking at microgrids. It's truly global. Actually, I'm a big proponent of the fact that the developing world is really where most of the action is. It's certainly where all of the load growth in the future is going to be, because the developed countries have leveled out, where we've got just as much energy efficiency kicking in, counteracting, and distributed renewables counteracting any load growth, which has kind of diminished. But the developing world is where all the new load growth is happening, and they're adopting microgrids and looking at microgrids very rapidly. It's hard to tell, but there's certain places like East Africa. See if I can use this point here, where there's the dot in India and Indonesia and the Philippines and South Africa, where the dots are just on top of each other. There's hundreds of dots there that you can't see them. So I like to categorize things, so I break the world up into categories, or the types of microgrids into categories. And the big issue is, are they grid connected or are they off-grid? And in the off-grid world, I make a distinction between what we call island utilities. They don't have to be geographic islands. So Canada has 30 remote communities that are electrical islands. And they're powered by diesels. Alaska has 200. Russia has 3,000, actually, and there's tens of thousands, literally, of inhabited islands around the world that are powered almost entirely by diesel, which is 3 times the cost of any other power source. So that's a place where renewable power is cost effective, where it doesn't take a whole lot of renewable power before you're at very high penetrations and you're dealing with issues that the large utilities don't have to deal with yet. But if we want to get to a future with truly clean power, the large utilities will have to deal with it. So those are island utilities where there is a utility company. It may not be very well resourced. It may not have a lot of technical or financial resources, but they've got poles and wires. They've got engineers maintaining the diesel. They're sending out bills and collecting them every month. There's an organization to work with. There's also 1.3 billion people in the world with no power at all. And microgrids, again, are in those places where they're living somewhat densely, tightly together, microgrids are the way those folks are going to get power. The dispersed people will probably have a solar home system. But it's a market, a very interesting market, a very compelling story about what it does to someone's life when they get power for the first time. And they can read at night, their children can do homework at night, a nurse is willing, or a school teacher is willing to stay in the village. It's a very, very compelling story. The challenge there is that there's no existing institution. So then on top of the technical issues of, well, what should the power system look like, you have an organizational issue of who should manage it and how does that work. But there's a huge amount of interest among development organizations. We work a lot with the World Bank and the Asia Development Bank, et cetera. There's a lot of interest in getting those last 1+ billion people connected to the modern world. That's in the off-grid world. In the grid-connected world, I make a distinction between resilience, which is what New York is really interested in, and it's that infrequent but really regional or catastrophic kind of outage, like the ice storm here 10, 15 years ago, 20 years ago, whenever that was, but like the tidal wave in Japan, terrorist attacks, earthquakes, tornadoes. There's all kinds of extreme events, especially weather events, where just having a backup generator is not good enough because you'll have one day, a fuel tank good for one day, and if you were the only one with an outage, you could get a truck to come give you fuel every day. That's fine, but if it's a regional outage, there just aren't enough fuel trucks. And that's what they discovered in Sandy, is you can't really rely on a backup generator for an extended period of time over an extended area, and that's where renewables and a more sophisticated smart microgrid can really help by at least powering your critical infrastructure. And so that's again what the New York Prize is all focused on. And so I make a distinction between that and the situation in the developing world, because here in North America, Europe, Japan, Australia, in the developed world, the utilities are pretty reliable. And yeah, sure, hospitals have backup generators, but they don't get used very much. The fuel consumption is trivial. And, but if you're in India or most of the developing world, those backup generators get used a lot. And every commercial entity, every hotel, every middle and upper class family has a backup generator, and they hate them because they're totally a pain. They're noisy and smelly, and they require maintenance. And if you use them a lot, they're actually pretty expensive. So that's another market for a microgrid that relies more on solar, might still keep the diesel as a backup, but doesn't use it very much, uses solar and storage as the primary source. So those are our four markets. There's a couple of smaller markets we look at, or niches, like the mining industry has a lot of remote loads, big remote loads. Ecotourism's not quite as big, but interesting. The military, it's already been mentioned. And telecommunication has all these cell towers, and it's an incredible pain for those companies to keep fuel trucks going up to those cell sites that might be on top of a mountain. If you're in the developing world, half the fuel gets stolen, the roads are no good, and microgrids are a great solution to that problem. So I look at this, so I've grouped these markets or these applications into, in this way, based on the value proposition. So reliability or resilience as a subset of reliability, if you will, and you've got the military up there and emergency services, critical infrastructure, et cetera. The places that burn diesel 24/7, it's all about fuel saving. It's all about the cost of diesel fuel. And 5 years ago, when fuel was really expensive, they were all panicking. They're kind of breathing a sigh of relief today, but the truth is that the cost of solar is coming down faster than the cost of diesel. This stuff is still cost effective, even more so. They're not panicking anymore, so there's a little more thought going into the design of them. In the long run, I think reduced emissions is the primary driver. We need, some kind of pricing on carbon, et cetera. So now it's just people voluntarily pricing carbon for themselves. But one of the things we argued about today, but in my opinion, It is easier to manage high penetrations of renewables in a microgrid where you, because it is kind of a complicated control thing to cover the clouds that pass, to cover the variability, et cetera. But that kind of management and control is much easier if it's your microgrid than if it's the big utility company trying to manage millions of individual appliances in individual homes. So we see microgrids and these remote areas as the pathway to a truly smart grid. You know, I live in Boulder, Colorado, which was supposed to be the first smart grid city, and it was a fiasco. They spent $40 million and discovered Boulder, Colorado they tried to bury dedicated fiber lines for the communication and discovered Boulder has rocky soil, which is surprising, right? But more seriously, the big utilities have serious security obstacles where they really worry about being hacked, whereas a microgrid, unless you're the military, the microgrid isn't really such a great target for a hacker. And they have regulatory obstacles. Trying to move anything through the regulatory system just takes a lot of time. There's a lot of stakeholders. They're all going to argue. And you often, sometimes at least, end up with what happened in California where the Enron scandal, they cut the baby in half and it didn't work, right? But in the smaller systems, you can experiment more easily. The economics are better because they're burning oil. And and it doesn't take much to get to high penetrations of renewables so I was in an Eskimo village in Alaska where as the wind goes up and down, the power going to heating appliances in individual homes is going up and down in real time through a wireless network. So that's the smart grid, and that kind of experimentation is happening around the world in microgrids, and that is the pathway to a clean power system. So thank you.